Well, a couple months ago, I became the new owner of this Powermatic 90 lathe, and I spent a lot of time getting it running. I finally got it working the way I want it to, and I just wanted to make a video going over everything I did and the steps and all the mistakes I made. So if you have something similar and you're trying to get it running, hopefully you can learn some stuff from it. The first thing people say when they see this is, wow, I used to have the same exact lathe in high school. And I think they were really common in high schools back in the 60s, 70s, 80s, 90s. And I think I also had a lathe exactly like this in high school. And a lot of the people who own lathes like this now bought them at school auctions. And you can get them, depending on condition and what comes with them, for $400 to $800. But I actually was lucky enough, and I got this one for free. A neighbor was moving and they had this in their garage. I think it was their father's. And they said, hey, if you can get rid of it today, it's yours. And I was like, great. And I ran in there and I tried to move it, and I could not even budge it. It's 600 or 700 pounds. The steel on this thing is super thick. But with the help of my wife and my father-in-law and 2 dollies, and we had a car jack, we got it on the dollies. It actually cracked one of the 2x4 dollies, but we ended up getting it across the street. We got stuck. It took us an hour. It was a big ordeal, but we got it here. And the first thing my wife asked me was, so does it run? And I was like, oh yeah, it definitely runs, when really I had no idea. And I looked for a plug, and there's no plug, but there was an electrical box in the back. There was 2 of them. And I opened it up, looking where, okay, I'll connect positive and neutral on there. Well, there was 3 spots for wires, and I thought, okay, one's probably ground or something. Well, it turns out this is a 3-phase motor. And I had no idea at the time what 3-phase electricity meant. All the tools I have are 110 volt single phase. You just plug them into the wall. And this is a 3-phase motor. And the best explanation I've had is kind of like a 3-phase is similar. It looks like if you think about it like a flux capacitor in Back to the Future, where it has 3 inputs and it's continuously turning the motor around, whereas an alternating current is on, off, on, off. So it does and it doesn't work together. I have this running on single phase, but it's not perfect. And I'll tell you how I got to that point. So I went online, I started reading, and some people said with kind of like a pony motor and a belt, you could get this up to speed, connect it to single phase, turn it on, and it would work. And I tried that. I connected it. I hadn't changed anything. I connected, let's say there's 3 plugs in the back, call them L1, L2, L3. I connect positive and neutral to L1 and L2. I tried to ramp this up, get it going, turn it on. All it did was just go bzzz, and it just buzzed. And I was like, well, that doesn't sound good. So the next option that everybody does, 90% of people that have these, is they buy a VFD or a VFC, which is like a variable frequency drive or a variable frequency controller. And what that is a box that you can input 110 single phase and you can output whatever you want. So you can have 110 single phase coming in, you can have 220 3-phase coming out, you can have 440 3-phase, you can have all sorts of stuff at different horsepowers, and those range between 150, 180 to anywhere up to $400 or $500. A popular brand that people buy is Tico, and you can mount it right on the wall. I'm going to eventually run an outlet here, but you can mount the VFC right next to it. You plug the single phase in, the 3 wires coming out run to the unit, and it works fine. And I still might do that. But I didn't want to jump in right away and spend $300 on that. So I tried to run it off single phase. It didn't work. My next option was to replace the motor. I didn't get rid of the motor. I just wanted to see if I could get it running on a single phase motor. So I started with this one. This was my grandpa's old motor. It's a 3rd horsepower, 1750 RPMs, and it's not small, but it's not as big as that has a 1 horsepower motor in it. This is a 3rd horsepower. And my first try was, I was going to take this pulley. This is called a Reeves drive, and it's really ingenious how it works. Where the pulleys variable, the size, the diameters will change. You adjust the top one, and the spring automatically adjusts the bottom one. That's how you can go from 1,000 to 4,000 RPMs. It's constantly changing the size of the pulley, which is similar to, I have a a drill press, and it has 4 different size pulleys on the drive and the motor, so you're manually changing them depending on what speed you want. This you can get any speed you want. So it's really nice. So I was going to take that bottom Reeves drive and mount it onto this motor. Well, that's like a 3/8 or ½ inch size shaft, and this is a lot smaller. So I tried to make a coupler. Well, you have to machine that so perfectly to fit. The way this fits right now, it's kind of like the bolt action on a rifle. It's so precise. When I tried to put it back on, the Reeves drive was out here in the cold. It's like 30 degrees in this garage. I tried to put it on there. It didn't fit on the drive shaft. I had to take it in the house, let it warm up so the metal could expand just to fit it back on there. That's how tight it is. So I couldn't mount that on this motor. I failed to do that. So I thought I'll just make my own pulley. So I made this out of wood, a couple pieces of plywood, and I figured it would at least work, and it did. I had kind of a 1-to-1 ratio. I couldn't adjust this, but I mounted this motor. I dropped the original motor down and mounted this in its place, and I had a 1-to-1 drive, and it worked. It didn't have any torque. If I tried to cut too hard, it bottomed out, but I was able to make some stuff, and it worked. But that was just a test, and I was happy. That seemed like everything worked fine. My next option that I came up with was I was going to use the original motor in place, put this below it, use the original motor as something like a jack shaft, where I made this pulley, and I made a new pulley on this belt, and I was going to run a belt to this pulley, and this would be mounted on the original motor in between the Reeves drive and the motor. So this would be in the middle. So I would be running this to run that motor. Then I would still have the Reeves drive, and I could adjust the speed. It worked, but it took a lot of adjusting. When I mounted it, this is 3/4 of an inch wide, so suddenly this bottom pulley was off 3/4 of an inch, and the belt was on an angle. So I had to make new mounts for the motor in here to shift it over so this was in line. And again, it worked, and I could adjust the speed, but it didn't have any torque. So I went back downstairs and I realized I had a more powerful motor, and that was this one. This came out of an old dishwasher we had, and this is a 1/2 horsepower motor. And I had never got it working. I never tried to get it to run. I had all these, you could see all these different wires here. There's like 7 of them. And I went online and I looked up what all the different wires did, and I connected them. And again, this is single phase still. And I turned it on, and it just went bzzz, and it same noise that this motor made when I first tried to turn it on. And I took the drive shaft and I spun it and I spun it, and it eventually wound up and ran full speed. And I realized that this originally came with a capacitor, a small capacitor. And it got me thinking, and I connected this up to this motor, and when I turned it on, it immediately started running. And I had a flashback to this motor making that buzz and not running. So I took that motor out of there, brought it down to the basement, connected positive and neutral to the L1, L2, it buzzed. I spun up that shaft. Now it wasn't connected to all these belts and pulleys and drive shafts. I could spin it up by hand, and I got that motor to run on single phase by connecting positive and neutral to the L1, L2. Okay, this is a test of the 3-phase motor with single phase just connected to 2 of the phases without either capacitor. So it doesn't start right away, but I can hear it buzzing. If I wind it up, it took a little bit, but it does run. Then I read some more online, and they said, yes, you can do that, and you can use a capacitor. So I took this small capacitor and I bridged it. So I had L1, L2 connected to positive and neutral, and then I took this off positive or neutral, it didn't matter, and I ran this end to the L3. And now this capacitor would supply 220 volt. You can buy all different size capacitors. I bought another one of these on Amazon for $5. And when I turned the power on, that motor immediately started right up. Okay, this is the second test, and I now have a 189 227 MFD 110 volt AC start capacitor, which came off this old dishwasher motor. And I have one end connected to one of the phases and the other end connected to one of the phases that I have the AC coming in. And it starts right up. You don't have to get it going. It immediately starts up. I notice it does turn off quickly and it does jump in the beginning, but it starts right up. And I thought, this is it, this is going to work. And that's what I have in there right now, and it seems to be working now. I'm not great with electricity. I don't know if it's running at full power. I don't feel like it is. It seems a little slow to start up. It might be lacking some torque. It's only running at 110 volt instead of 220. So it's not running at its full power, but it seems to be going fast enough once it gets up to speed. And I've seen people run these motors with a lot larger capacitors. I've seen people running three-phase motors with a bank of like pop can size capacitors, and that might be the way to go. But for $5 you can buy one of these small capacitors and get it to work. So I mounted this up, and I'm running these. When I originally did these test motors, I ran the power directly to the motor. I didn't have to use the boxes in the back. So I made a power, and I bought a potentiometer, because when I was running it with a direct drive, I thought, you know what I might be able to do is just dial down the power. So for I think 15 bucks on Amazon, again, I bought a potentiometer that I put in a box, and I could dial down that power. It worked a little bit, but not great. But now I can still use that with this motor. So I have this running, power coming in to a box right here. I put another box on the inside. I have power coming into that and running through the switch and potentiometer. So I'm not using this box on the back at all. I just have a plug running directly to it. So let me show you how I can get it to work. Again, in the future I'm going to have a box right behind it, but for now I'm running this. So this is power going into the box through the switch directly into the motor. And you can see, I usually have it pretty high on the full power on the potentiometer. But it starts right up and runs fine. And again, that's running on 110 volt single phase. It's a three-phase motor, but with that capacitor, it's giving it that boost to get going. And I can speed it up to 4,000, turn it back down to 1,000, and with this potentiometer, and I can turn this all the way down to, say, if it's at 1,000 here, I can probably turn it down to 500 RPMs. I wanted to go through and kind of show you the tools I used to get it all apart. Like I said, I haven't cleaned it up or anything. I've just got it running, and I'll show you how I had to take stuff apart and fix stuff in the end stop. So let me show you how I did that. So we got this here, and the first thing I did to try to get it working was to get inside this case. This was a big piece of steel that goes on the end, and it covers up the drives, and I keep that on there 90% of the time. But to get that off, you first had to get this metal plate off, this aluminum plate that goes on the end, and I could not get it to move. I tried, first it was hard enough to get this to stop spinning, because I don't have, there's usually a plug here to, you put it in there and it locks the shaft in place. I didn't have that, so I took this, half-inch Allen wrench, I shoved it in there, and when I went to turn this, it bent it. That's how much force it was taking. So I had to get a hardened steel shaft to put in there to lock it in place. Then to get this off, I first started with this small pipe wrench on here. That didn't work. I went to this pipe wrench, and that's how much force, pulling as hard as I could to get this off. And it's not a reverse thread if you're looking at, it's correct if you're looking at it from the machine. If you're looking at it from the back side, it's a reverse thread. And I actually wrote on here loosen and tighten, so I remember. To remove it, you're pulling it toward you from the top, but you have to lock this in place here. So I got this off. I was able to get that cover off. It's just one large bolt, and that's how I was able to work on it from the inside here. To work on the motor, you have to get on the inside and look up and from the side here. Again, here's the cable that I took off. Like I said, I have it running directly to the motor, but there's a mount in the back. There's 4 bolts in the back, and it's pretty tough to get in there, but I was able to get the motor down and remove it. Again, like I said, I mounted a box here and 2 boxes here. I didn't drill directly into the lathe, the steel, so I mounted it underneath. I have the 2 boxes in the back, which I didn't touch. You're going to need some good Allen wrenches, some large ones too, because you need the small ones to get the little Allen screws off, because there's a lot of Allen screws all over the place, and some large ones to adjust this Allen bolt on the front. And this one seems to come loose a lot. I took this plate off. On the inside there's a small activation switch, because traditionally this works, you have it wired directly, there's always power, and to start it you just turn this wheel, and once it gets over a certain point there's a connection and there's a spring-loaded switch. Well, since I have that bypassed, it doesn't matter anymore. This end stop was all rusted when I first got it. It did not move. This was off. There was no nut holding it on, and I actually had to go to Lowe's or something to get the right nut, and it was not hard or not easy to find. It was in one of those specialty bins. It's a 1/2 inch 20 fine thread. So if you're looking for the nut on here, it's 1/2 inch 20 fine thread. I took this whole internal, I finally got the inside out, and I took that whole thing to find the right thread. But this eventually works. I had to do it, there's a cap on the end with a little cut in it, and I had to pound that out to get this loose, and then I could mount it, and now it works. And I oiled it all up, so now it spins. The tool rest, this was initially, when I got it, it was broken. The handle was broken off. Somebody probably tried to tighten it too much and it snapped. I took a grinder and I cut a little V on either side and I welded it up. So I welded this handle back on, ground it smooth, so you can't really tell other than the grind marks. This large tool rest was snapped, so I again welded a little piece on here. It wasn't really level, and I tried to tap it back down after I used it a few times and it snapped off. It's pretty hard to weld this. It's really thick steel, so you got to get a really good penetrating weld. So I'm going to weld that back on there. It originally came with this large cover, this plastic cover. I haven't seen that on any other lathes like this. It seems more like a machining cover, but that was on there. I don't really have any use for it, so I took it off. Other than that, I haven't cleaned it up. It runs super smooth, so I've seen people put sandbags down here, but I haven't seen the need for it. Some things I bought. First was a drive center. I got this on Amazon for 18 bucks. I was gonna make my own, but I figured for 20 bucks, it's something you really, it has to be pretty good. It's not the end of the world to buy one. I did have an end, the pointy end stop here, so I didn't need to buy one of those. But I did buy this chuck plate to screw onto. Again, this is, a lot of lathes are 1 inch for the threaded end. This is 1.5, so make sure you don't buy a 1 inch, get the 1.5. And this was 20 bucks. And I'm gonna use it for making bowls. That's what I really wanna make with this, is some bowls. So you're gonna need this, and you're gonna mount it on the end. It screws on, and you'll use screws to mount the log on. But I also wanted to make my own chuck for it. So this is kind of where I'm at right now. It's still not working. I'm still not getting a really good grip on a piece. but I'm making these little teeth to just manually adjust. I'll try to maybe get like a metal hose clamp that'll clamp it from the edges, and then I'll tighten these down to grab it. One thing I did buy though was a set of chisels and gouges. These I got on Craigslist for 50-60 bucks. They're pretty old, they're marples, but I really liked them because they were well made. So I'm really looking forward to using this. Let me know what you think. Let me know if you have any other suggestions of what I can do. So I'm going to go through, clean it up. I'm not going to paint. I've seen people paint it. I like the way it looks now, so I'm just going to clean it up, oil it up, and hopefully get some use out of it. Well, I hope you liked the video you just watched. If you did, feel free to subscribe by clicking the button on this side. You can also check out all the videos I've done, the playlist from things I've built, things I've fixed, home repair, 3D printing, and on this side you can check out a recommended video similar to the one you just watched. And as always, down in the description I'll put a link to my blog, which has more pictures and more information about the video you just watched. Thanks.